Today is day 10 of your STAAR review, and in this video we will be discussing dilations and scale factor. Now, just to jog your memory, this is the foldable we will be looking at first, and let's go ahead and get into it. So the first thing we're going to do is go ahead and identify those terms on that front page. So first we have a scale factor. Now, we use a scale factor to multiply both our x and y values to dilate an image. So to find our scale factor, we can take our new over our old. Now we can do this by dividing our side lengths, or we can divide points. Then we have a reduction. So here I started off with a big triangle and this went to a smaller triangle. So here this tells me that my scale factor is less than 1. And whenever we reduce these, they are similar figures. So that means that they are the same shape but a different size. Then we have an enlargement. So here I went from a small triangle to a large triangle. So here our scale factor is greater than 1. So again, these are similar figures, which means it is the same shape but a different size. Then you have congruent. So here I have two triangles. They are the same size, they're the same shape, they are equivalent, and they have all equal angles. And then I have, lastly, similar figures. So here I have two of the same shape, however, they're different sizes, but they have equal angles and they're proportional. So I can use box and tail, for instance, if I had a missing side, to find the missing side. So that being said, this is everything you should have written on your foldable. Okay. So now you can go ahead and close this up. These were your definitions that you needed to know for dilations and scale factor. And you're going to go ahead and open it up this way. And we're going to go ahead and look at number 1 and 2 first. So number 1 says graphic P is dilated about the origin to make larger graphic Q. Which rule best represents the dilation applied to graphic P to make graphic Q? So they're telling us we're starting off with P and we're making Q. So this means P is my old, Q is my new. So the way I can do this again is I can pick 2 points off of my image or of my graphics here. So to find scale factor, we're going to take new over old. So again, our Q was our new, our P is our old. Here we're going to go ahead and divide our points. So I'm going to go ahead and pick a pretty point, and I see that I have a pretty point here at 2, 2. And then I have a pretty point here at 5, 5. So I have, for my new, I have my point at 5, 5. So I can take, to find our scale factor, we can divide our x's or we can divide our y's. So here I'm going to go ahead and divide my x's. So 5 divided by my old x, which is 2. 5 divided by 2 is 5 over 2. So here my scale factor is 5 over 2, which means A is my answer. I'm just taking that scale factor and I'm putting it in front of x and y whenever it comes to an algebraic representation. Now, if you wanted to count side lengths, so again, you would take new over old. You would count the side of each and divide them. So we can start off by counting the side of our new. So here I have 1, 2, 3, 4, 5, 6, 7 and a half. Now, typically, I only recommend to count side lengths whenever they land on pretty points. So here our new is 7 and a half. Divided by our old side length, which is 1, 2, 3. And 7.5 divided by 3 is 2.5. It is 2.5. And if I were to convert this, if I go back and if I leave it as a fraction, so I can take 2.5 and I can convert it to a fraction, and here we get 5 over 2. So again, here we see that we get the same scale factor of 5 over 2. Either way you attempt to solve this. So looking at your foldable, This is everything you should have written down for number 1. So if you need a second, pause it. Otherwise, we're going to go ahead and go on to number 2. So number 2 says graphic J is dilated about the origin to make graphic K. Which rule best represents the dilation applied to graphic J to make graphic K? So here I'm going from graph J and I make graph K. So here, graph J is my old, graph K is my new. Now here I want you to take note. I started off with a very big graphic and I went to a small graphic. So this here would be an example of a reduction, and therefore my scale factor should be less than 1. So I can go ahead and eliminate A and C because my scale factor is greater than 1 in those answer choices. So again, to find my scale factor, I'm going to take my new over my old. So for this one here, I think it'd be best if we go ahead and use points. So here I have J at 6.2, and I have K at 3.1. So I have the point 6.2 for J, and for K, I have 3.1. Again, K is my new, J is my old. So I'm doing new over old, and again, we can either divide our x's or we can divide our y's. Here we can go ahead and divide our x's or our y's, it doesn't matter. I'm going to go ahead and divide our x's. So for our new x value, we have 3. For our old x value, we have 6. And whenever we simplify this in our calculator, 3 divided by 6 is 1/2. So here, my scale factor is going to be 1/2. So here your answer is going to be D. Now going back to number 1, since I just want to emphasize here that we started off with graphic P and we went to graph Q. Now here, that means my image got bigger, which means this is an example of an enlargement. Now, some of you might have automatically eliminated A and C because you saw that they were fractions, and therefore you thought that your number was going to be less than 1. You need to make sure you remember that these are improper fractions. So 5/2 does simplify to 2.5, so that number is greater than 1, which does mean it would be an enlargement. But going back to our foldable, let's go ahead and see how you should have this filled out. So again, just make sure you have everything written down here. Pause it if you need to. Otherwise, you can go ahead and close this up. Now, you're going to go ahead and open it up. And first, we're going to go ahead and look at number 3. So number 3 says, which transformation of a figure on a coordinate grid preserves congruence? Now, going back to our definitions, we see that congruent means same shape, same size, it's equivalent, and it's equal angles. So, in order to preserve congruence, it should stay the same size and the same shape. So here at A, I have a scale factor of negative 0.5 and 0.5. Therefore, if I apply these scale factors to my image, it's going to make it smaller. Therefore, it's not going to preserve congruence. Again, same size, same shape. So A is not my answer. Then looking at B, I have a scale factor of 2. Again, if I have a scale factor of 2, that's going to make my image bigger. So that is also not preserving congruence. And then the same thing with C. I have a scale factor of 3. Whenever I apply that to my point, it's going to make my shape bigger. So C is also not correct. Then I have D. So D here, multiplying an image by -1 is not going to affect the size. So, and here they also flipped it. So here D is the only one that would preserve congruence. Looking at number 4, it says, which transformation on a coordinate grid does not preserve congruence? So now I'm looking for the one that changes the size and shape of an image. So looking at A, I have x comma y, and then I have a scale factor of 5. So having a scale factor of 5 means that my image gets bigger, so it does not preserve congruence. So this one looks like it could be my answer. Again, if you're trying to preserve congruence, if you have anything in front of x and y that is not 1, it's going to change the size and shape. So therefore, A is our answer. But looking at B, again, I don't have a number in front of x and y, so that's going to keep congruent. All C is going to do, this is a translation, so this is going to just slide my image. So therefore, that does preserve congruence. It does not change the size or the shape of my image. Now, D is a reflection. This is a 180 degree, this is a rotation. This is a 180 degree rotation. Now, rotating my image does not change the size or the shape. It just turns it. So D does preserve congruence, and again, the only one that does not is going to be A. So, taking a look at our foldable now. This is everything you should have written down. And again, if you need a second, just go ahead and pause. Otherwise, we're going to go ahead and look at number 5. So number 5 says trapezoid ABCD is dilated about the origin to make trapezoid ABCD prime as shown. The angle measure of trapezoid ABCD and the corresponding angle measures of ABCD can best be described as, okay, so now we're looking at angle measurements. So here, I see that this image has been reduced. Okay, so this is a dilation. My image has been reduced. So it changes the size. It's the same shape. But my angles do not change. I still have the same angle. Because if you look at angle B is similar to angle B prime. They are the same angle, they are equal, therefore they are congruent angles. So B is my answer here. Then I have number 6. It says quadrilateral ABC is dilated about the origin to make quadrilateral ABCD prime. The side lengths of quadrilateral ABCD and the corresponding side lengths of ABCD prime can be described as. So if you look here at our side lengths, for starters, we see that our image gets bigger. So here I had a side length of 1, 2, and 3. Over here, I now have a side length of 1, 2, 3, 4, 5, and 6. So here I see that my image got smaller and my side length got larger. So it cannot be congruent because it is not the same size or same shape. And again, equivalent means it is equal, and they are not equal to each other. Perpendicular, I'm not even sure why that's thrown in there. And F is your answer. They are proportional. This is everything you should have written down for number 5. And then this is everything you should have written down for number 6. So now lastly, we're going to go ahead and look at number 7. So number 7 says quadrilateral ABCD is dilated about the origin to make quadrilateral ABCD prime as shown here. Which is true regarding quadrilateral ABCD and quadrilateral ABCD prime. So looking at our answer choices here, it says the angles of quadrilateral ABCD and ABCD prime are proportional and the side lengths are congruent. So here I see my side lengths are not congruent. Again, congruent means equal, and they are not equal because one is bigger than the other. So A is not my answer. Again, I just want to emphasize to you, whenever we are enlarging something or reducing the size of something, it does not change the angle measurement. They are still congruent. So looking at B, it says the angles and the side lengths of quadrilateral ABCD and ABCD prime are proportional. So for proportional means that it is the same size. The same size but a different shape. Now in similar figures, the angles are the same, but the sides are proportional. So what does proportional mean? So proportional just means that It's the same shape, but a different size. So, yes, your side lengths are proportional, but your angles are congruent. So, B is incorrect. Then I have C, the angles of quadrilateral ABCD and ABCD prime are congruent. Yes, they are. That is true. And their side lengths are proportional. That is also true. So this one looks good. This one's true. And then D says the angles and the side lengths of quadrilateral ABCD and ABCD prime are congruent. Now remember, congruent means equal. So while my angles are congruent, my side lengths again are not equal, so that cannot be my answer, and C is. So now looking at your foldable, this is everything you should have written down for number 7. And again, just remember for dilations, angles are the same, side lengths are proportional. And again, proportional just means same shape, different size. So that was your foldable for dilations and skill factor. Before you complete your assignment, make sure you watch the video going over similar figures.